take a look at derivative of logarithm function, okay? We know the derivative of ln x is 1 over x. Then if you have a chain rule, then derivative of ln u will be 1 over u, but because it's chain rule, so you have to times u prime. Okay, so this is the logarithm, the natural logarithm. So the base is e. So this one have the base is e. Now with any other basis, so you're gonna have a logarithm of base a of x, then it's gonna be different. So the formula will be 1 over x, but you're gonna have ln x, ln a. The reason why you don't have ln a here, because base e, ln e is 1. So if you do ln e is actually equal 1. So that's why we don't need to write ln e. Or they are pretty much the same thing. And the derivative of logarithm with any base, but the u is actually is a u, right? It's any function, then you're gonna have u prime over u times ln a. Okay, so we're gonna apply that. All right, so let's find the derivative of this logarithm function. So this is ln, the logarithm, the base e, right? The natural log of base e. And the argument of the ln is actually not a single x, but it's actually a different term of the algebraic function, right? So you're gonna have u. So your u will be whatever inside your parentheses. This is your u. Then the derivative y prime will be 1 over u times u prime, right? So 1 over whatever inside the parenthesis, whatever inside the parenthesis, and then times u prime. What is the u prime? U prime is a power, I mean, you apply power rule, right? U prime will be 6x per 3. So you're going to have this times 6x per 3. And that's going to be the derivative of logarithm. If the problem may be a little bit more complicating for like y equal log space 3 of secant x per tangent x, right? Then this is going to be the logarithm of u. So you're going to have chain rule still. So you will have u prime. So what is your u here? Your u here in this case is secant tangent, right? So this is your u. So you remove that. So this is your u. So u is secant x per tangent x. And u prime will be what? Derivative of secant is secant tangent, if you still remember the rule. And then the derivative of tangent is secant squared x. So based on the logarithm rule, we have to first apply the logarithm rule and then doing chain rule. So we're going to have 1 over, the logarithm rule is 1 over u, which is secant x per tangent x, times ln of, what is the a? A is 3. A is 3, so ln of 3. Okay, and then times secant x. So we can put that in the numerator by doing u prime over that is fine too. So secant x tangent x plus secant square x. Now, look like on the numerator, I have secant is the same, so we can actually take out secant x. And then tangent x plus 1 over secant x per tangent x over ln 3. And then from here, you can see, oops, not plus 1, plus secant x, right? Because you have secant x squared. So you're going to have secant x. And that will give you secant x over ln 3. Okay, so if you are about to finding y prime, then you're going to find y double prime. This is y prime. This is y prime. Y prime is equal to secant x over ln 3. Okay. And now what did the y equal ln 3x? Yes, your u is 3x, right? Then u prime is 3. So derivative of ln u is 1 over u times u prime. So 1 over u times u prime, so that 1 over x. Okay, so that's all you need to do. All right, so let's do a little bit complicating one. So if I have y equal ln of 3x per 2 over x squared per 2x, then what is my u? My u in this case is the one that is a quotient. So this problem, you will have derivative of ln, and then plus what rule? Quotient rule, chain rule, and then quotient rule. Chain rule and then quotient rule, right? So first, you're going to have to take the derivative of ln first. The derivative of ln is 1 over u. So remember, I showed you in class, when you have 1 over a fraction, it's just the reciprocal. So you can flip them. So 1 over u times u prime, right? So 1 over u will be the reciprocal of that fraction. So we will have this over 3x per 2. And then that's going to be your 1 over u. And then now times u prime. So because your u is 3x per 2 over x squared per 2x plus 1. Okay, times u prime is the chain rule. Now we're going to take care of u prime. In the u prime, you're going to have a quotient rule. So u prime. So derivative of the numerator, right? Low d high. So derivative of the numerator is 3. High, low, right? You have low d high minus high d low over low squared. Okay, so I'm gonna have low d high. So you can have x squared plus 2x plus 1. D high is 3 minus high d low will be 2x plus 2. And I mentioned a lot of time that when you have any expression that have multiple term, make sure you put in the parenthesis, otherwise your result will be wrong. Okay, and then now all over low square. So it's going to be x squared plus 2x plus 1 squared. And now we're going to simplify this. We have 3x squared plus 6x plus 3, right? You distribute that. And then minus this one, if you distribute, you're going to have negative 6x squared minus 6x minus 4x minus 4. Okay, and then now all over x squared plus 2x plus 1 squared. I see some people will expand the denominator. Try not to. When you apply quotient rule, just leave it as a factor form. Okay, and then u prime will be negative 3x squared, 6x and 6x is gone, and then we will have negative 3x squared minus 4x, and then minus 1, and then all over this stuff, plus 1 squared. And then we will put back in here. We have negative 3x squared minus 4x minus 1 all over x squared plus 2x plus 1 squared. Okay, and you will see, because this is the multiplication, so we can cross canceling. So I can have x squared plus 2x plus 1 cancel with one of the power. So we will have this gone and this gone. Okay, so then our answer will become negative 3x squared minus 4x minus 1 over 3x plus 2. Okay, 3x plus 2. I forgot to multiply x squared plus 2x plus 1. Right, because we only cancel one of the factor. It's not all, so you still have one more. Okay, so this is going to be your final answer. All right, so there's another way to find the derivative of logarithm without apply the quotient rule. However, you will need the derivative property, okay? I mean the logarithm property. So let me show you how to do that one. So when we have y equal ln of 3x plus 2 over x squared plus 2x, x squared plus 2x plus 1, right? Then if some of you still remember the logarithm of a over b, this is the property, okay? It's going to be ln of a minus ln of b. So it means the logarithm of the numerator minus the natural logarithm of the denominator. So it means this function can be end up to be rewriting as ln of 3x plus 2 minus ln of x squared plus 2x plus 1. Then that will help you to break down into two individual logarithms. And if I want to take the derivative of the first logarithm, my y prime would be the derivative of logarithm is 1 over u times u prime, right? So this is my u. This is my u, and this is also my u. So 1 over u, which is 1 over 3x plus 2, times u prime in this case will be 3. And then here we will have 1 over u times u prime in the second natural logarithm is 2x plus 2. Then we're going to have the y prime will equal to 3 over 2. 3 over 3x plus 2 minus 2x plus 2 over x squared plus 2x plus 1. Okay, if you want to leave your answer like this, it's fine. If you want to double check whether your answer will be matched with this, you can also expand by multiply the numerator and the denominator, right? So multiply this, we have 3 times x squared plus 2x plus 1 minus 2x plus 2 times 3x plus 2. And then all over x squared plus 2x plus 1 times 3x plus 2. Okay, when you expand the numerator, you will see that it's actually this thing right here. They are the same thing. Okay, so the result should give you the same answer if you expand it. All you can leave is at this step. Then you don't have to stuck with the quotient rule. Okay, so this is something that I want to mention here.